Let's talk about value types and reference types. We know that the CLR is going to support these two different types. Value types are going to be allocated onto the stack in memory. And what that means is they are going to be served very easily within memory. And they're going to be pulled and pushed onto and off of the stack as they need to be. So they're going to be dropped out of memory when they're no longer in use, say within a class, for example. After that section of the class, or maybe a for loop, then these are going to be dropped off of the stack after they're no longer needed, based on the scope of the variable. Reference types are going to be managed by the heap. These are .NET managed, and that means that they're going to be garbage collected. We'll talk about that in a little bit. This is the .NET Universe way of actually working with our objects to allow for a formalized way to get rid of them when they're no longer needed, and we'll see that later. But these reference types can consume a lot of memory, a lot of resources, but they definitely have more features and benefits over the simple value types. These value types are much smaller, and we'll talk about the features of those as well. For example, if we look at the primitive or basic types, like your integers, your longs, these are your basic primitives that we talked about. Structures are also value types, and enumerations are also value types. These value types cannot be null, and they must contain data. Reference types, on the other hand, deal with your classes, your interfaces, your strings, because strings are reference types. They work like value types, but they're reference types. Your arrays and delegates, for example. These are your typical reference types. Now, what are the features of working with and benefits of working with these value types? Well, like I said, they're small and they are allocated onto the stack. They cannot be null. They must always contain data. Now, when you pass these value types, when you're using methods, for example, we'll take a peek at that, they are going to be passed by value. That means that they're copied as new objects when you pass them into methods. And this means that the original is never going to change. You're only actually creating a copy, and then if you manipulate that copy within your method, then that copy is going to be changed and not the original because they're copied. Value types are low in performance and also memory because these types are very, very small, and that's really good for you and good for me. So value types don't necessarily have to worry about that, so that's why that copy isn't such a problem. Now, I know it can be pretty difficult to understand the difference between value and reference types. There are many different ways to think about this. In C++, you're talking about pointers and so many different ways that can get very, very complex. The basic natures of how we're going to be passing our value types through our methods, this is going to be a primary concern, and how they're dealt with when we actually are done with them. We don't have to destroy them, we just have to stop using value types. At the end of that method call, they're going to be popped right off of the stack and no longer in memory, so that's great. Note that these are derived from system.valueType, and they're sealed. When a value type is sealed, this means that once you have derived a class from this system.valueType, then no one else can actually derive from your class that you're creating. So you can actually derive from system.valueType, and that's more of an advanced concept in how you're programming and things like that, but that's just for your information. In reference types, now, these can consume significant resources, more resources, but they have more features. You can imagine if you have a big class, a big object, these are going to take up a lot of resources, and they have to be handled differently. Now, reference types can be null, and they're going to be heap-based, like I said, .NET managed. When you pass these reference types in methods, you're passing by reference. You're only passing a reference to the object. Now, when you change this reference, you're actually changing the source data, because that reference is pointing to where the data is located in memory. So that's the important thing. When you pass through into a method, and then you make changes in that method, then you're actually changing that data, because when you pass by reference, you're referring to that object, and that's why it can be changed. Now, the reference means that we're not going to waste resources because we're not copying the object, and that's pretty simple to think about. We're not copying the object, the same data is going to be used, so we're not wasting resources. When you deal with structures, you have to worry about, am I passing a big structure here and wasting a lot of memory? And this is a concern for you. You have to actually think about that while you're putting together your programs and your methods and things like that, and your data structures. Now, cost is going to be an issue when it deals with performance and memory, because references have to be managed by the .NET heap. This is going to affect the CPU, and then these must be garbage collected. Garbage collection is the .NET way. When something is garbage collected, then it's going to be managed, and you have to wait for a particular cycle in order for that object to be taken out of memory. So it does need to be managed a certain way in your programs, in your thinking, and you have to understand the garbage collection, and we'll discuss that later. Now, you don't know when this garbage collection is going to occur necessarily, and there's a process called finalization. Finalization is the closest thing to destruction in C# and the .NET world. C++, you're thinking of destruction. So it's close, but it's no cigar. So it's something that we'll discuss when we talk about garbage collection. So we'll just take a peek into Visual Studio.NET, and I'll just show you just a method call here that is passing by value and then passing by reference. We have an array of integers, an object. These are passed by reference, and then an integer passed by value. We'll talk more about this as we move forward.